안녕하세요. 제 이름은 Sunil Mallya. That's only the Korean I know, so I'll talk in English from now. So let's talk about Amazon SageMaker today. So SageMaker allows you to build, train, and deploy your machine learning models. There are three distinct components to SageMaker. There's a part that allows you to host notebooks so that you can build your code, collaborate with other developers. And the next part is training. Once you have the code that's developed, you can use SageMaker to train the model in a distributed fashion. So it's not just training on a single machine, but you can use multiple machines. As far as the algorithms are concerned, we give or provide 10 of the most popular classical machine learning algorithms, but also allow you to run the latest and greatest of deep learning models. Once you're done, we also provide hyperparameter optimization so that you can find the best hyperparameters that are suited for your application or your model. And then the final piece is once you've trained the model, you need to deploy it, right? You need to actually consume it. Again, we make it easy for you to host and deploy the models with very minimal amount of code, as we will see later. But more importantly, it's at scale. So there's an auto-scaling endpoint that can scale with the traffic patterns that you have. So let's look at what algorithms does SageMaker provide. The classical machine learning algorithms that I talked about, something like matrix factorization, principal component analysis, k-means, gradient boosted trees, all those are provided. Also, we allow for you to use MXNet, TensorFlow as a native runtime. And there's connectors to Apache Spark, so you can integrate that with your data pipeline and call SageMaker from Spark. And finally, we understand that people have their own needs or custom algorithms. To enable that, you can use or Dockerize your needs and bring that into SageMaker. What we set out to do with SageMaker was actually truly build algorithms that can scale with the data that you have. What we found was a lot of customers had terabyte scale or multi-gigabyte scale data sets which couldn't be trained in traditional or implementations. So we built a way to scale these algorithms, and we will dive deeper in this talk. So again, this is done for all the machine learning algorithms that SageMaker provides. So what do we mean by these infinitely scalable machine learning algorithms? So there are three ways of ingesting the data in SageMaker. So you can have your data in S3, you can get EBS or EFS, or you can actually pipe the data through SageMaker. But what's really that makes it scalable is the streaming nature of how the algorithms work. So let's see what we mean by that. So let's take a chunk of data. With streaming, it means is we don't need to wait for all the data to come in. Right? Let's say you have 5 gigabytes of data. You don't need all the 5 gigabytes. If your chunk size is 1 gigabyte, you can just start operating on this 1 gigabyte of data once you get it in. So there's a state that's maintained, you can constantly iterate, and as new chunks come in, your state gets updated, and then your model building happens at the same time, and finally you have your model that's created at the end. What this allows for you is we can now run in almost constant data time. Let's say your footprint is 1 gigabyte in the example we took. Now we can just execute the entire thing with just that constant memory that we have. And as a result, what you see here is we linearly scale as the data size increases over time. But that's great, right? We saw a single machine case, but what we really want to understand is how does this work across different machines? Because you really want to execute faster. And in this example, we have a cluster, 3 machines. What happens is these machines maintain a shared state that get exchanged, and each of the individual machines can work on different chunks, so you can parallelize the algorithms, so you get faster training. And in general, what we have seen is the SageMaker algorithms perform similar to these graphs. So this area, right, where you ideally want the algorithms to be trained faster, so around here, and it should cost less. That's the ideal area for the algorithms that we target. Okay, so let's look at some of these algorithms that we mentioned earlier. So this is the linear classifier. So and we have 2 examples. One is a regression and classification. So in case of the regression, spam or not, you can see SageMaker trains faster. So it takes around 6 minutes, whereas the corresponding implementation elsewhere takes about close to 25 minutes, right? It trains faster and it's cheaper than the algorithm. Same is the case for the other example with classification. Now, k-means clustering, so this is an unsupervised example. So people who are not familiar, we have multiple data points and we are trying to cluster them. So as you can imagine, clustering with just 2 clusters is easier than, say 1,000, because you really have to find samples that are close to each other. Now, even in this case, where we have examples that go from 1 gigabyte to 1 terabyte, what we see here is, in this 1 gigabyte example, as we increase the number of clusters, the algorithm is really almost 10x faster than a regular implementation or previous stock algorithms. And also, as some of the algorithms fail to train on large data sets, that's not the case in SageMaker. We also bring the latest and greatest of algorithms, making them available in SageMaker. So this is a deep AR, deep autoregressive for time series-based forecasting. This is internally used at Amazon.com, where we use this to forecast the sale for a particular item. So in this examples, we've done electricity forecasting or traffic forecasting or page views. So there are a lot of applications that you can use this for. And what's cool here is you don't need to be a data scientist to use this. You can literally provide a JSON file of, let's say you want to do page views, so you provide page 1 and the counts, and then you can provide that data over time in a JSON file, and it gives you back the forecasting. You don't need to understand how the algorithm works internally, but you can consume it just like you would consume APIs. So it's that simple. And also in this example, you can see for a massive data set, it's only cost $1. Let's take a look at how the SageMaker console, and in general, what's the feel there. I'm just going to switch to SageMaker. So this is using, what we have is you can, once you go to the console, you can spin up a machine and a notebook interface is made available. So data scientists might be familiar with Jupyter interface. For others who might not know what Jupyter is, it's an interactive way. It's a living code document. You can interactively execute, comment, and keep track. It's a really nice way to collaborate. So here we build a movie recommendation engine with SageMaker. We use the Movie Lens dataset where you can download the data. And the idea is we're basically building a user recommendation for movies. So I'm sure everybody loves movies here. What you'll see is people watch some movies, and then you want to know what rating might somebody give, or maybe they like a certain movie based on other movies they've watched, which has many, like in retail and other use cases as well. Any sort of recommendation engine can be built this way. And then with SageMaker, here the regular code where you're importing some of the libraries, you get this set. So you do the data processing step, which you would do with any sort of machine learning. But more importantly, the actual code that does the training and what you need to do as a user from a machine learning point of view is only 3 lines of code that you see here, right? You build an estimator with the file that you want to run, or how many instances you want to train, and set the hyperparameters, and then finally provide the data and call this fit function. So it's really that simple. You're basically formatting the data in a certain format, and then these 3 lines of code allow you to build a user recommendation or any kind of a recommendation engine. It's that easy, right? In the example that we saw, we only had 100K movie recommendations, but imagine if we had 1 million or 10 million or 1 billion. What do we do? Right? Like, there's a lot more data. Guess how many lines of code it takes to actually build this at scale? Just 1. So you can do is you can just increase the number of instances as you see there, and that's about it. Now, you don't need to build the distributed or parallelizing the algorithm. It's built in. So all you need to do is specify the number of instances, and SageMaker does the undifferentiated heavy lifting of parallelizing and coordinating and building you the model. So it's that easy. Once you have done, let's say you wanted an endpoint, with a single line of code, you can take the model that's saved in S3 and then use it here to actually create an endpoint that you can consume internally or externally. And also, for enterprise customers, this might be important to keep the data and keep the whole process isolated. SageMaker has the capability to run entirely in your VPC, but also there's KMS integration where the data that's stored in S3 gets to your instance in a secure way and is actually, KMS decrypts the data. So end-to-end secure training can be provided with SageMaker. Okay, I think we're back. So now we've looked at the built-in algorithms. What about the latest and greatest in deep learning and neural networks? So we have support for that as well. So in this case, here's an example of image classification. We provide a notebook and actually steps on how you can build an image classifier. You can bring the data in the same way we saw earlier, and then call modify the template for your use case. And it's great. Again, you see here in this example, we're using Apache MXNet. We can scale almost linearly across the different number of machines. So there's another session in a bit where one of my colleagues is going to talk about Apache MXNet in detail. So I'll show an example with TensorFlow and how to use that in SageMaker. Here's an example of using a ResNet architecture on CFAR10 dataset. And you'll see this pattern where most of the code you're writing is initializing your session and setting up your environment. And the real deep learning or machine learning code that you're writing is very minimal. So we first upload the data to S3. And as far as you're concerned, we can give that data, and we just need to call the estimator just like we did previously. So you give it a script file which hosts your training code, and then you give it the number of training steps, how many instances you want to train on. You can use CPU-based instances, or you can just use like the P2 family, which has the K80 chipset, or we can use the P3 instances to actually train. So there's flexibility in what instances you can choose, also the number. But what's great about it is you only pay for what you use. Once your training is done, the cluster automatically shuts down, and you're not paying a single penny more than you have to. There's also a mode where you can, data scientists are probably familiar, you'll execute a few lines of code or a few epochs or batches to understand how the model learns before you spin up a cluster, right? So for that purposes, what you can do is use like the local mode, where the training will happen locally on the instance. And then once you're satisfied that, well, this is likely going to run, you can use in many more machines and do a distributed training. So it's really flexible in how you get to use this. And you get this nice output here where you can check out the logs and how the training happens. And as for TensorFlow, there is TensorBoard integration as well, where you get an endpoint where you can access and check more stats on how the job actually ran. I wanted to highlight some of the more recent customers who've used SageMaker references. So we have Intuit, Hotels.com, Thomson Reuters. We've even got in the healthcare space, GE Healthcare, Tinder, Grammarly, who've been using SageMaker to simplify their end-to-end machine learning platform. So as you can see in this list, there's really a large number of different customer segments that are using SageMaker effectively at massive scale. And one such example is Intuit, who's using real-time fraud detection in AWS using SageMaker. So they have a data pipeline with Kafka, and they also use, they just data with Kafka. They use Spark to process that data. Like you can hook Spark and call SageMaker directly to build an end-to-end training pipeline. So you do the training, and you can use S3 to store that model. But the good thing is you can now take that model, run locally, or SageMaker has the hosting interface where you can build your API endpoint. And the good thing is, as I mentioned earlier, there's auto-scaling support for SageMaker, so you can actually scale your endpoint up and down. I'm going to switch. We also provide sample notebooks. So as you log into SageMaker, what you have is this GitHub repo that has a lot of different examples. So for people who are new to machine learning, I really encourage you to go check out what SageMaker has to offer. So you have examples for, as we saw, like movie recommendation, or for linear learners, or k-means clustering. So for each of the algorithms, we have a lot of different examples. So you can actually take that code and bring your data in and use it to model. And people who are new to this, you can execute existing examples that allow you to learn faster, or you get hands-on experience to get familiar with machine learning. So don't be afraid. And let me tell you a little story. Like I was talking to one of the customers, and they seem a little scared or apprehensive about machine learning. So think of this as like driving a car, right? Most people don't understand the internal mechanics of a car, and you sort of have this idea of throttle and steering and brakes. So those are your interfaces to actually driving a car. Now, similarly with SageMaker, you actually don't need to know exactly how the algorithm internals work. All you need to know is these are the knobs or things that I need to change. And I bring my data in, put it in a certain format, and then push it in. And then SageMaker is able to model that and build the models and host. So you really get this nice knobs that you can use to actually build your models at scale. So if we sort of summarize what does SageMaker bring to the table, it's an end-to-end machine learning platform. Our aim is to actually bring the time from you getting the data all the way to having a model. We want to reduce that cycle. And that's what SageMaker aims to do. There's zero setup time. Right? As you've seen, you just need to create a notebook instance, and it gets built up, and you can start using that. Flexible model training. There's native support for Apache MXNet, Gluon, and TensorFlow. And we are bringing more of the other popular deep learning frameworks in, as well as native citizens. But also there are machine learning algorithms, the classical ones like k-means, factorization machines, LDA. All those are available on SageMaker as well. And you pay by the second. You're not paying a single dollar more than you have to. The cluster automatically shuts down when you have done training. On the auto-scaling side, for the hosting part of the model, as the traffic patterns change, your infrastructure can adopt so that you're not really paying for idle instances. So here are some resources that I recommend going. So we have a lot of blogs that we publish on SageMaker, so I encourage you to go check out. There are a lot of examples. And a lot of customers write stories on how they've used SageMaker. There's a really cool story about this person in Vietnam who had no idea about machine learning. In 1 week was able to build a model that could identify buildings from satellite imaging. So it's really easy to get started, so I encourage you to take a look at these resources. Here's the link for Summit. With that, 감사합니다.